two variable function fxy is equal to 5 minus 4 sin x plus y square, where the domain for x is open interval 0 to 2 pi and domain for r is all real line, means complete real line. The set of critical points of x y consists of a point of maximum and a point of a local minimum, a point of local maximum and a saddle point, a point of local maximum, local minimum and a saddle point, a point of local minimum and a saddle point. So first understood what is the meaning of critical point. So critical point is a point where gradient of the function is either 0 or doesn't exist. And stationary point is a point where gradient of the function is 0. It means that partial f with respect to x and partial f with respect to y is equal to both are 0. And in this case, partial f with respect to x and partial f with respect to y both are 0, or one or both doesn't exist. So we will find those points where partial derivative of the function either 0 or not exist. So this is the meaning of critical point, and I try to relate stationary point. All stationary point are critical point. Stationary points are critical points, but all critical points are not stationary point, because of in critical points one extra condition where one or both partial derivative doesn't exist. This makes sense. All critical points are not stationary point. So we will find partial derivative of given function, as given function f of xy is given by 5 minus 4 sine x plus y square, and domain of x is coming from 0 to 2 pi, this is open interval, and y is coming from entire real line. So fx will be minus 4 cos x, fxx will be plus 4 sine x, fy will be 2y, and fyy will be 2. Similarly, fxy will be 0. So required partial derivative we have calculated. Now we will check sign of fxx fyy minus fxy square is, if it is equal to 0, then no conclusion, means we need to investigate further. If this is less than 0, then point is saddle point, where the condition of this is 0, then the point is saddle point. If greater than 0, then point of extrema. I am saying point of extrema, not saying local maxima or minima. So this will be the point of extrema, but if one of them, either fxx or fyy, if less than 0, then maxima, point of maxima. If greater than 0, then point of minima. So we have to check nature of the point at we have to check nature of this fx x fyy minus f square xy at the said critical point. So try to find critical point. First, fxx or fyy exist everywhere. So there is no condition where partial derivative doesn't exist. Now second condition is where partial derivative is equal to 0. So if fx equal to 0, then we have minus 4 cos x equal to 0. This implies that cos x equal to 0. So x equal to either 0, pi by 2, 3 pi by 2. But 0 will not include here because of x is coming from 0 to 2 pi. 0 to 2 pi. So we have value of x only these two, pi by 2 comma 3 pi by 2. And by the condition fy equal to 0, we are getting 2y equal to 0 means y is 0. So critical point or set of critical point, this is the set of critical point will be pi by 2 comma 0, y coordinate always 0, and 3 pi by 2 comma 0. So this is the critical point. So we will check nature of fxx fyy minus f is square xy at this critical point. So this is the table critical points fxx fyy minus f square xy. This is fxx or fyy, and this is nature. What will be the nature of critical point? So first critical point is pi by 2 comma 0, and second point is 3 pi by 2 comma 0. As we already calculated or not, I'm checking. So not calculated. So we check fxx fyy minus f square xy. So put all these what we have after getting fxx value of fxx is 4 sine x, and fyy is 2 minus f square xy is 0. So this is 8 sine x. So check at the point at pi by 2 comma 0. So at pi by 2 comma 0, because of sine graph, this is sine function graph. So pi by 2, this is pi by 2 means pi by 2 up to pi. If x is coming in this range, then sine is positive. So pi by 2 is coming inside, or if I can take right closed. So at pi by 2 comma 0, because y coordinate is 0, so this is positive. And fxx or fyy is 2, also sin x is also positive. So this is point of minima. So this is positive, and this is in also positive, and nature is mean or local minima. Now check at 3 pi by 2 comma 0, as value of this is 8 sine x, and at the point 3 pi by 2 comma 0, because of sine function at 3 pi by 2 or after it, this is negative. So nature is saddle point. So no need to check fxx or fyy sign, because of we are getting this is a negative, and there is no need to check sign of this, and it will be the saddle point. So we have two critical point, one is point of minima and other is saddle. So First option is saying local maximum. So option this discard. Local maximum, again this option discard. Option C, local maxima, minima and saddle point. So option C also discard because of local maxima. We have only two, nature, minimum and saddle. So option D is true. A point of local minimum and a saddle point. So one point is point of local min, and this point, as you can see on my screen, we have only two critical points. One of them is a minima and the other one is a saddle point. So pi by 2 comma 0 is minima, and 3 pi by 2 comma 0 is saddle point. So option D is correct. The number of generators of the additive group Z36 is equal to. So this Zn, or particularly Z36, this is Z36 with respect to additive modulo 36 is a group, and we have to find number of generator. So if this is a result, or you can say formula, in Zn additive modulo n, the number of generators can be find out with the help of Euler totent function phi n or Euler phi function. So value of n is 36, and this one can be written as 4, 9 is 36. This means 2 is square into 3 is square. So phi n can be written as, means phi 36 can be written as phi 2 raised to the power 2 into 3 raised to the power 2. This value of this function, phi function, will be 36 into 1 minus half into 1 minus 1 upon 3. So this is 36 into half, and 2 by 3. 2 3 2 3 is 6, and 6 6 is 36. So 12 is the answer of phi 36. You can do this one with the help of phi mn equal to phi of m into phi of n, where these mn are coprime, means GCD of mn is equal to 1. So which one option is giving the value 12? Option B is correct. F is a function given by this expression, and you can see mod function involved in this expression. We write L equal to left hand limit of fx, as you can see, at 0 negative, and R is right hand limit, it is at 0 positive. Then which of the following is true? L exists but R doesn't exist. L exists, L doesn't exist but R exists. Both L and R exist, neither L nor R exist. So we have to test left hand limit and right hand limit for function fx at 0. Keep remember, for this function, continuity of the function doesn't ask, because of function is not defined at 0. So how can we find limiting value of the function and exact value of the function at the point we doesn't find, or we can't find. So to solve this problem, we only find limit, either left hand limit or right hand limit. For left hand limit means L, and is given by limit x tends to 0 negative fx. So fx is given by the structure x plus mod x, and within bracket 1 plus x divided by x, and in numerator you can consider sine 1 upon x. So we, whenever mod function involve, always try to resolve mod function for positive value and negative value. So I can write when x is positive, so mod will be x. So 1 plus x divided by x into sine 1 upon x. For negative value, mod x is minus x, 1 plus x divided by x sine 1 upon x. This is the structure of fx for x greater than 0 and for x less than 0. Further, you can simplify for this x, or you can take x as outside, so it will cancel out by this one. So left term will be 1 1 plus 1 plus x, and sine 1 upon x is also there. Second term, this term will be 1 minus 1 minus x into sine 1 upon x. So what we have? We have for 2 plus x sine 1 upon x, uh, and this one cancel out. So minus x sine 1 upon x. On further simplify, I can write 2 into sine 1 upon x plus x into sine 1 upon x, and for this I can write simply x sine 1 upon x. So this is defined for positive value, this is defined for positive value, and this is for negative value. Now find left hand limit and right hand limit for function. So L will be limit x tends to 0 negative, fx will be limit h tends to 0 minus x, or I can write 0 minus h sine 1 upon 0 minus h. So for this, what we have, limit h tends to 0 h into sine 1 upon minus h. So sine minus x is equal to minus of sine x. So I put minus here and make it positive. So this is somehow look like as minus of limit h tends to 0 h into sine 1 upon h. As sine function is bounded, you can observe the graph of sine function, and h is tending to 0. So after putting limit, this is look like 0 into some bounded value, because of sine value of this sine is oscillate between two numbers, means 1 and minus 1. So 0 into some bounded number will be 0, means limit of left hand limit exists and is equal to 0. Now work on right hand limit. So expression for right hand limit is this, as I oval the part by red marker, 2 sine 1 upon x plus x sine 1 upon x. So r will be limit x tends to 0 positive fx, and this one is equal to limit h tends to 0, it will be 2 sine 1 upon x, 2 sine 1 upon x plus x sine 1 upon x. So you can observe this limit will not be 0, means it doesn't exist. How? Because of whenever you apply limit concept here, it will form h into sine 1 upon h. So h is tending to 0. So sorry, limit of this part will exist, this h tends to 0, 0 into some bounded function. So limit of this part is 0. Limit of this part is 0, but limit of this part is not equal to doesn't exist. How? 2 into some bounded value. But sign have no fixed value as we tending to 0 from right hand side. So we have many values, but it is bounded by 1 and minus 1 we can see, but no fixed number. So limit of this part is not exist, not exist, but limit of this part exist. So finally r doesn't exist. So what we have, L exists and R doesn't exist. So which one option is true? Option A is L exists but R doesn't exist. So option A is correct. Let f is a function of variable x and y, and the structure of the function is given by this format, and this format is for all those order pair which are not equal to 0 0. Then partial f with respect to x and f are bounded. In other options, one of them is asked about boundedness and other is unbounded. So we have to check function and its a partial derivative, means partial f with respect to x and f, we have to check its boundedness. And when we deal function in one variable, what is the meaning of boundedness? A function f is said to be bounded if all images, mod of all images is less than or somehow real number. So suppose this is less than equal to by m, so function said to be bounded. In this is a two variable function. So what will be the properties of boundedness? Means all images should be less than a particular number, as we are dealing in two variable. So it's somehow complicated to deal two variable. If anyhow we can reduce this function in one variable or single variable, so we can easily observe this boundedness. So as you can see, the structure of the function is given by x square y, and in denominator x square is y, x square plus y square. Whenever x square plus y square either present in numerator or denominator, always try to transform xy coordinate system in polar coordinate system, so you can easily solve problems. So you can put substituents as r cos theta and y as r sin theta. So this problem will reduce in polar coordinate. That means suppose this is a xy coordinate system, and suppose in particular direction this is theta, so you fix theta, then this is a radius r circle, this is higher radius circle, and so on. So entire xy coordinate system you can observe in polar coordinate. So check in all direction, it's complicated. So in direction of theta or fixed direction, you can observe the boundedness and its partial derivatives, so you can answer this question easily. But as if you not interested in polar coordinate, you can make substitution as y equal to mx, and this substitution will help you in denominator as x square y upon x square plus y square is given. So it will transform this structure of the function in single variable. How? This will be mx and x square divided by x square plus m square x square. So you can take x square as a common in numerator from numerator and denominator. So left term will be mx upon 1 plus m square. Now the function can be considered as in single variable, and we can easily check boundedness of this function. So how we can say, as this structure is mx upon 1 plus m square, and it will be less than equal to mx upon m square, it will cancel out, so it is less than equal to x upon m. As limit x tends to infinity, we can say that x upon m tends to infinity. So function is unbounded. Function is unbounded, means not bounded. Unbounded in the direction y equal to mx. In particular direction, function is not bounded, so we can say entire function is not bounded over the entire domain. So option A is saying f is bounded, so this discard. F is unbounded in option B and in option D. So possible answer may be option B or D, but A and C discard because of boundedness of f. Now check partial derivative. As we obtained the structure of function in one variable as fx equal to mx upon 1 plus m square. So f prime x will be m upon 1 plus m square, and this is again less than equal to m upon m square, and this will be less than equal to m 1 upon m. For different values of m, we have different bounded or different upper bounds, but function derivative is bounded, means f prime x is less than equal to some b. We can choose this b according to m. As we are choosing m, so we can choose a b for which f dash x is less than b, means partial derivative is bounded but function is unbounded. So option B is correct. Matrix M is given to us 1 upon 2, 1 by 4, 0, 1, and x is a column vector 3, 4. Then limit n tends to infinity m raised to the power n x. We have to find limit of m raised to the power n x. What is its meaning? Because limit of a matrix we had not defined till now. So what is the meaning of this expression m raised to the power n x? Limit of this one is the meaning obtain integral power, positive integral power of m raised to the power n, and apply limit concept on the constituents of the matrix, because matrix M is of the size 2 by 2, so all integral power of m raised to the power n will be 2 by 2 size matrices, and apply limit concept on elements of these. Here these are elements of matrix integral power of m. So apply limits on these and take product with column vector 3, 4, and you will get answer of this problem. If limit of its element integral power of m is exist, then B, C and D, from among these you will get a unique answer. If is not limit of its constituents it not exist, then option A will be your right choice. So first our target is find integral power of m. As m is given to us, so its integral power m square will be 1 upon 2, 1 by 4, 0, 1, 0, 1. This is a matrix M, and we need to take product itself 1 upon 2, 1 by 4, 0, 1. We will obtain first entry first generalize the pattern how we are getting elements of integral power. So third entry will be, because 0 is here, so it will multiply here and 1 to this number, 1 to this number. Always we will get third entry 0, and fourth entry, how to obtain fourth entry? 0 to this one, and so you will get 0 plus 1 to this one, so fourth entry will be 1. Now remaining entry are first and second. In first row, it means first row is we need to generalize in all integral power, we will obtain second row 0 1. So its first element will be 1 upon 2 square, and second element is 1 upon 2 into 1 upon 4 plus 1 upon 4. Now MQ will be this previous matrix. Previous matrix is 1 upon 2 square and 1 upon 2 into 1 upon 4 plus 1 upon 4. This is 0 here and 1. Take product with matrix M. 1 upon 2, 1 upon 4, 0, 1. So result will be 1 upon 2 raised to the power 3. It means we know the first element. If 3 is here, then we will get 3 here. If n will be here, then we will get n. It means integral power of n is the power of 2. So first element of m raised to the power n is 1 upon 2 raised to the power n. Third element is 0 and fourth element is 1. So we need to generalize only second element. Second element is we will get in m raised to the power 3 1 upon 2 square into 1 upon 4. This entry, this first row with this column, this first row with this column. So first entry will be 1 upon 2 square into 1 upon 4 plus 1 upon 2 into 1 upon 4. This is my entry, and 0 here and 1 here. It means 1 upon 2 raised to the power 2 into 1 upon 4. Because if 3 here, then we get 2. So when n will be here, then we will get 2 raised to the power n minus 1. And this term is same as because of 1 here. So entry on previous element will come here. So in integral power of m raised to the power n, so I am going to write here element of this one. It will be 1 upon 2 raised to the power n, 0, and it will be 1 here, fourth entry. And second entry, how I am getting second entry? Second entry will be 1 upon 4 plus 1 upon 2 into 1 upon 4 plus, and so on up to 1 upon 2 raised to the power n minus 1 into 1 upon 4. This is my second entry. All elliptic part is my second entry. So second entry is 1 upon 4 into 1. 1 upon 2 into 1 upon 4. 1 upon 2 square into 1 upon 4. So we need to only generalize this element only. M raised to the power n is 1 upon 2 raised to the power n, 0, 1 upon 2 raised to the power n minus 1 with product 1 upon 4 plus 1 upon 2 raised to the power n minus 2 into 1 upon 4 plus and so on up to 1 upon 2 with 1 upon 4 plus 1 upon 4. How many terms are in this? This is n terms. N terms, and this is 0 here, third entry, and fourth entry is 1. Now take limit. Now take limit, or you can product with m raised to the power n with column vector x. So first I'm going to take limit, because in the product this terms only adding. We will obtain, how we will obtain a column vector 3, 4 and its product. So 3 multiply here and 4 in this. So indirectly I will either apply limit concept later or earlier. It doesn't alter the answer. So limit over this one. So limit of first element will be 0, because 1 upon 2 less than 1, and if we get 1 up raised to the power n, then this one will go to 0. So first element, limit of first element is 0, and limit of 0 is 0, limit of fourth element is 1. Now come to this point. This is 1. Take 1 upon 4 as a common. So first element is 1 inside the bracket, second element 1 upon 2, and third 1 upon 2 square, and so on up to 1 upon 2 raised to the power n minus 1. This is geometric series. This in square bracket, this is geometric progression with common ratio half. So its infinite sum can be evaluated by the formula a upon 1 minus r. A is 1 here and 1 minus half, so it will be 2. Now 2 here, 2 I obtained from this bracket and need to take product with 1 upon 4. So 1 upon 2. So my matrix limit n tends to infinity m raised to the power nx is, I already applied limit here. So I obtained 2 here, 1, 0, 0, and my column vector is 3, 4. My column vector is 3, 4. I obtained 2 here, or 1 upon 2. Sorry, it will be 1 upon 2. You can check here. This is 2 into 1 upon 4. This is in the last 2 into 1 upon 4. So product will be half. So take half here. It is half into this matrix, column matrix. So result will be 1 upon 2 into 4. It is 2, and this one is 4. So 2, 4. This column vector is our answer. Now check which one option is giving 2, 4. Option C is giving 2, 4. Column vector 2, 4. So option C is our right choice. Let script M be the set of all invertible 5 by 5 matrices with entries 0 and 1. For each M, any matrix belongs to script M set, then N1M and M not M denotes the number of ones and zeros in M respectively. Then we have to find minimum of their difference. What is given to us and what examiner want to ask about this question. This script M is 5 by 5 invertible matrices. It means no eigenvalue is 0, or in other terms, determinant of all matrices all matrices not equal to 0. If any set, if any matrix belongs to this set script M, and suppose this is a matrix, any matrix, then this matrix contains only 0 1 0 1 0 0 0 0, contains only 0 and 1, then number of, for this symbol we use number of ones. Here you can see there are two ones, so it represented by n1, n1, 1 denoting number of ones in set M or in matrix M, and zeros is denoted by n naught M. It means number of zeros in matrix M. So notation is so good to describe this problem effectively. Now we have to find their difference, mod of their difference. It means you can see number of ones in this matrix is 2, and number of zeros 1 2 3 4 5 6 7. So their difference is 5. 2 minus 7 or mod of 7 minus 2, both values are 5. So we have to find this value, minimum of this value. Suppose any matrix other than this matrix we got the difference 3, then 3 is minimum. If for a particular matrix we got difference is 1, then we have to choose 1. If we have such matrices having difference 1 3 5, then their minimum is 1, so we have to opt 1 for this particular example. So come to the point. Script M is 5 by 5 non-invertible matrices and contains only 1 and zeros. 1 and zeros. This is a small superscript used for plural case, plural numbers. And this M belongs to set M, and this is also non-invertible. It means no eigenvalue is 0 and its determinant is not equal to 0. And this matrix contain only zeros and 1. So let us consider this is 5 by 5 matrix. So first trial and error method we use. This is 5 by 5 matrix, and make this matrix non-invertible. I choose 1 at diagonal positions only. 1 in diagonal position, and make it triangular matrix, because triangular matrices having eigenvalues only diagonal elements. So if I make this matrix triangular, then its upper entry, suppose 1 0 0 1 0, this type. How many entries I have total ones and total zeros? This is 5 by 5 matrix. 1 2 3 4 5. So 4 entries, 4 zeros are here, 1 2 3 and 4, 1 2 3 0 0, and suppose this one 1 2 3 4. So total entries are 1 2 3 4 5. Total zeros are 20 and total ones are 5. So their difference is 15. Difference is 15. Total difference or difference of n0 minus n1 is 15. Now make some entries. We want this difference equal to 1. We want this difference of n0 and n1 equal to 1. It means how I can get 1. Suppose I want to make entries because there are 25 total entries. Let v1 equal to 110 and v2 equal to 011. Let M be the matrix whose columns are v1 v2 2 times v1 minus v2 v1 plus 2 times v2 in that order. Then the number of linearly independent solution of the homogeneous system of equation mx equal to 0 is. We have to find number of linearly independent solution. Number of linearly independent or Li solution of the system mx equal to 0. This is nothing but nullity of M. Nullity of M is asked about. First see what is M. M is first column is 1 1 0, second column is 0 1 1, and third column is obtaining by 2 times v1 minus v2. So you will get 2 minus 0 2, 2 minus 1 1, and 0 minus 1 minus 1, and fourth column you will obtain by v1 plus 2 times v2. It means first entry will be 1 3 and 2. So this is matrix of this size 3 by 4. So find this is coming from linear combination of v1 and v2. So these columns are not linearly independent. Only independent columns are these two. So rank of this matrix M is 2, and nullity by rank nullity theorem, nullity of this matrix M is equal to 4 minus 2 is 2. Why 4? Because if you represent this matrix or associated linear transformation called T, it will be R4 to R3. So this is domain. R4 is domain. So dimension of domain vector space is 4. So 4 minus 2 is equal to 2. So number of linearly independent solution for this system is 2. This is the answer. Or you can find directly rank and number of free variable for this matrix. Suppose this is x1 x2 x3 and x4. The number of free variable in this matrix will be nullity. Let T be a 7 by 7 matrix of rank 4 with real entries. Let A belongs to R7 be a column vector. Then the rank of P plus A transpose is at least. It is important word, at least. Means the possible rank of P plus A transpose, but in least. So what is given? P is 7 by 7 matrix and rank of this matrix is 4. Also field is real means entries of P coming from real field. A column vector A is coming from R7, so A can be written as or of the type A1, A2, A3 and so on A7. So this is vector A and this is column vector, so you can write transpose here. Then the rank of P plus A transpose. If this is A, then its transpose will be same matrix, same vector here. So it is compatible for product, no doubt. Also we will get, because this is 7 by 1 and this one is 1 into 7, so output will be 7 cross 7 and P plus, because size of P is 7 by 7, so compatible matrix for addition will be 7 by 7 of the same size. And we have to find rank of, this is row, this is row symbol, and this is matrix P, capital letter P plus A transpose. So this is well defined, and this is rank never be negative. So this is indirect information which is given to us. Now we know the inequality or rules or method formulas, as you can understand. Rank of product of matrix, if product is possible, is less than equal to min of rank A, rank B, and less than rank of A plus rank B minus common number in size which make product possible. What is this mean? If A is 7 by 5 and B is 5 by 6, then common number is 5, which makes these two matrices compatible for product. So this number is 5. So rank A plus rank B minus 5, it will comes here. So normally or in general we write n here. N is, this is the compatible, this is m into n and n into r, so n is common number. So this is first formula for product, and for sum of two matrices is can be sum of individual rank, less than equal to sum of individual rank and greater than difference rank A rank B, because this is difference should be more here, because rank never be negative here. So these two are formula or inequality we have, and we have find least possible rank. Least possible rank. So it means least possible rank. Somehow he is asking about lower bound. Lower bound of sum of rank. So rank of A plus B, because matrix P plus A transpose. So write matrix rank of P plus, so normally I write rank because P is given. So otherwise rho and P you can misguide. P plus A transpose, because this is sum, so it will less than equal to rank of P plus rank of A transpose, and greater than equal to rank of P minus rank of A transpose. So take mode here. A transpose, because rank of this is product and A is 7 by 1, so its possible rank is 1, because rank is min of numbers in size, min of numbers in size. So 1 is minimum value in the size, so its possible rank of this one, this is 4, rank of P is 4 and its possible rank is 1, because rank of A transpose will be less than rank of or min of rank A comma rank of A transpose, and this is number is nothing 1. So 4 plus 1, this is rank P plus A transpose, and rank of P is 4 minus, and this rank is 1. So 4 minus 1 is 3. So 3 less than equal to rank of P plus A transpose less than equal to 5. So least value is, or least possible value is 3. So answer of this problem is 3 here. Alpha, beta and gamma, alpha, beta, gamma, delta with the eigenvalues of the matrix. This, then alpha square plus beta square plus gamma square plus delta square equal to. It means if anyhow we can find the values of these eigenvalues for this matrix, then we can easily square them and add them, and we will get answer of this particular problem. So how to find eigenvalues of this matrix? As if you focus on this matrix, first row is 0 0, and in second row first leading element, and then in last minus 2, then 0 minus 1 0 minus 0 1 0 1, and 0 0 1 2. This is the matrix of the size 4 by 4, and this matrix having values in last entries or in last column, and all non-zeros entries which are represented by hash symbol is in echelon form. In echelon form, it means if this is first non-zero entry, then all entries below this non-zero entry is 0. If this is second non-zero or leading entry in next row, then entry below this non-zero entry is 0, and so on. So this is the size, and it look like this: 0 1 0 0 column wise, 0 0 1 0 0 0 0 1 0 minus 2 1 2. So this is last column, this is last column, and you can see this is non-zero entries. This is first non-zero, so all entry below this non-zero entry or leading entry in downward direction is 0. This is second non-zero entry in coming row, and entry below this non-zero entry is 0, and this is non-zero entry in last row. So this type of matrix is known as companion matrix. Companion matrix. And in companion matrix, all entry in last column is represented by minus of A1, minus of A2, minus of A3, and so on, minus of A4, and it will go like this to the top row or top position of the element. If this type of matrix is given to us, then we can easily write characteristic polynomial for this matrix. The characteristic polynomial of this matrix would be of order 4. So x raised to the power 4 plus, here particularly this is terms containing trace. So this entry, because elements in main diagonal or principal diagonal are 0 0 0, and in bottom this is 2, so this is 2 times this is negative of 2 x raised to power 3, because this is represented by minus a1, and general form of this characteristic polynomial will be x raised to the power 4 plus a1 x cube plus a2 x square plus a3 x plus a4. So this is the form of characteristic polynomial. So this is the value of 2 is the value of minus a1. So value of a1 is equal to minus 2. So minus sign here. Then again minus 1, or normally write minus x square plus 2 x and plus 0 equal to 0. This entry is known as known as determinant of the matrix, and this last entry is known as trace, because this is last entry in Kerr polynomial. So in last entry we use as a determinant, and first entry is as a trace. So this is value of trace, and topmost entry is determinant. So determinant of this matrix is 0 here, and trace of this matrix is 2. If this question can be asked what is the determinant and trace of this matrix, so you can easily, without finding, you can tell about. So this is x raised to the power 4 minus 2x cube minus x square plus 2x equal to 0 is our characteristic polynomial. I write again x raised to the power 4 minus 2x cube minus x square minus x square plus 2x equal to 0. Minus x square plus 2x equal to 0. Okay. Now find the root of this matrix. So take x cube common from first two terms. So x minus 2, and also x square or x take common from last two. So x minus 2. So these two are common bracket or common factor. So common x cube minus x equal to 0. Now factorize this one. So you can take x as a outside. So x minus 2 x and x square minus 1 equal to 0, and further you can write x minus 2 x plus 1 and x minus 1 equal to 0. So these are x equal to 2, 0, minus 1 and 1. So choose any one as alpha, beta, gamma and delta and take its square. So square will be 4, 0, 1, 1 and take their sum to find the value of alpha square plus beta square plus gamma square plus delta square, which is equal to 6. So answer of this problem is 6.